Based on the video shown, we can see that there are two parking scenarios shown, angled parking and perpendicular parking. The first question focuses on the angled parking scenario. So the car park is designed to fit cars with maximum dimensions as shown in this table. DE and DF are equal. DE as in DE and EF, and FG is perpendicular to DE, which also means that this is a right angle. The angled parking scenario is modeled in diagram 1, which is shown here. Given that DE is 5.3 meters, which means this is 5.3 meters, calculate the value of the turning area shaded in green, which means that they want us to calculate the area of the screen space. So in this situation, what we can do is first we can calculate the value of the area of the entire sector. We can actually see this is sort of a sector that we can possibly find in a circle. And the formula for calculating the area of a sector is pi times square of the radius, as well as the angle being shown. So with this formula, we'll find the sector. And to find the turning space here, we can minus it with the smaller sector that's shown here. So there are actually two sectors. There's one larger sector outside here, and there's one smaller sector inside here. So if we were to minus the two, we would be able to get the turning area shaded in green. So it's pretty much the same formula, except that there's two different radiuses. And to identify what the radius is, you see pi is the same. The radius, we can see that for the larger sector, the radius is pretty much given to us, d to e, so we know it's 5.3. So we know the radius for the larger sector. As for the smaller sector, we can actually see that they say that the width of a car is 1.8, which means this length is 1.8 meters. So in order to find the radius of the smaller sector, all we have to do is minus 1.8 by 5.3, in which we will get 3.5. So using this, we would get 10.36725576, in which we can say it's 10.37 meters squared. So that's the value of the turning area shaded in green. Moving on to the second question. Find the value of the minimum lane width, e.g. to the nearest one decimal place. So this time they want the value of EG. And one way we can find the value of EG is we already know the value of DE, which is 5.3. To find GE, we could possibly minus it with the value of DG. So this is what we would have to find out. And if we look properly here, we can see another right angle triangle right here. Since this is a right angle, we can also assume that this is a right angle. So we already know that DE is equal to DF. As previously stated in the question, DE and DF are equal. So DF would also be 5.3. In this case, we already have the length of DF, so it will be easy to find the length of DG. We could do this through the usage of cosine, which is the adjacent over the hypotenuse, in which the adjacent is DG, is what we want to find, and the hypotenuse is 5.3. So DG would be cos 75 multiplied by 5.3, in which the answer would be 1.37. And finally, to find the value of GE is what the question, EGGE is what the question wants. All we have to do is minus DE by DG. We already know DE is 5.3 and DG is what we just calculated, 1.37. In this case, we'll be getting 3.928, which is 3.9 meters, which is the minimum lane width. Moving on to question 3, which is one of the longer questions that you receive in IB MYP Criterion D. You are the designer in a planning department. Below is your brief for a car part design. So we can look at they give us a brief for a car part design that they would like us to design. They give us the purpose and certain conditions that we have to fulfill. Purpose, design a car park to maximize the number of parking spaces in order to make the best use of the land as a resource. Conditions, use either perpendicular parking or angled parking, but not both. Use 5.5 meter as minimum lane width for the perpendicular parking and 4 meters as the minimum lane width for the angled parking. So they actually give us, first let's take a look at the instructions.